With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
In Quincke's experiment, the sound detected is changed from maximum to a minimum when the sliding tube is moved through a distance of 2.5 centimeter. Find the frequency of sound if the speed of the sound in air is 340 meter per second. So it is given that the amplitude of sound changed from maximum to minimum. So if this is a sound wave and this is the excess pressure and this is X, when amplitude is maximum, it means that it is a pressure antinode. So the sound detected is changing from pressure antinode to pressure node. So in this graph, this is the maximum amplitude and this is the minimum amplitude. So we know that difference between two antinodes or two nodes, that is, if we have two antinodes, these are two antinodes, and the distance between them is equal to lambda by 2. Now instead of distance between two consecutive antinodes, we need to find the distance between antinode and a node. So this will be half of lambda by 2, that is lambda by 4. Therefore, the value 2.5 centimeter will be equal to lambda by 4. This implies we get wavelength lambda of the sound equal to 10 centimeter or 0.1 meter. We need to find the frequency of sound. So we know that the speed of sound v is equal to lambda into nu. So we get nu equal to v upon lambda. V is given to us as 340 meter per second and lambda is 0.1 meter. So this is equal to 3400 hertz, or we can also write the frequency nu equal to 3.4 kilohertz. This is the answer.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.